Good morning, chat. I am late by 35 minutes. Welcome, everyone. Yeah. Well, I don't know if my alarm went off. I think it did. Then I went back to bed, I think. And then I woke back up. It's freaking cold. That's my excuse, alright? Alright. Chat, we are back with more Long Drive. I don't even remember where we were. It's been like a good month or so since we last played. Okay, apparently we were in the building. Let me get out of here before I start reading. What were we doing last time? I assume we looted this basement already. Yeah, I don't think I need to do anything else. Should probably set my mouse polling rate down again. Also, these music are a little bit too intense. Holy shit. Calm down. That's better. Anyways, mouse polling rate. Give me a second. Oh no, it's already down. Okay, well the game just runs like ass regardless then. Okay. Let's get back out. Okay, I wonder if we're ever gonna see like the end of the playthrough. Because we are 10 playthroughs in. It's like what, 30 hours at least? We still don't have a rare hood, I assume. Let me check if this is the correct save file. It should be. This was 1116. Did I save last time manually? 1116 150. Yeah, that is the latest save. Okay. Apparently I didn't do a manual save last time. So whatever. All right. Let's get back on the road before I start reading. Oh, this game controls like ass because it's running at like 20, 30 FPS. Okay. Holy shit. Is there something I can do about it? No, not really. Okay. Well, right, so last time we actually left off on the page after this, but I'm gonna restart at the heading once again. Right, so last time we were doing priority boosting. We are still on chapter 4 for threads. The whole chapter kind of flows over my head, but we're still gonna march on. Alright, so priority boosting after IO completion. Windows gives a temporary priority boost upon completion of certain IO operations so that threads that were going to wait for an IO have more of a chance to run right away and process whatever was being waited for. Although you'll find recommended boost values in the WDK header files by searching for hash define IO underscore in WDM.h or ntddk.h, the actual value of the boost is up to the device driver. These values listed in table 4-3. I didn't close though. Okay. You know, we're gonna reload. Apparently I didn't close the cap. Oops. Well, it's a good thing that we just started driving. So which one did I not close? That one's closed. That one's also closed. So what was leaking then? What the heck? Oh, isn't that one? No, that's empty. What? What was leaking? There's something in the trunk? Oh yeah, it is. Apparently that was open. Alright. Attempt number 2. Right. It is the device driver that specifies the boost when it completes the IO request on its call to the kernel function, which is IO complete request. In table 4-3, notice that the IO requests to the device that warrant better responsiveness have better boost values. It is really hard to drive when the game is starting like this. Right. So, yeah, last time we established that sound has a better, higher boost value. Okay, yeah, no, we're pretty sure we read this entire part. Okay, I think it's this part that we haven't read. Boost during waiting on executive resources. When a thread attempts to acquire an executive resource, e-resource, see Chapter 8 and Part 2 for more information on kernel synchronization objects that is owned exclusively, or is already owned exclusively by another thread. It must enter a wait state until the other thread has released the resource. To limit the risk of deadlocks, is this okay? Let's safely get down the road first. And I have a theory why the game is stuttering. It's because we have too much shit in our car. Like, the game physics is like trying to figure out what to do with it. Let me see if we can get rid of some crap. For example, we don't need this lantern. We don't need this empty can. We don't need this metal detector. I still know what it's for. What am I holding? Oh. Ammo pack, apparently. Okay, we have a lot of gas. Like a lot. Gas. What is this that I have? Tried to sneak in a hidden stream so I lose my watch streak? No, this isn't it's not a hidden stream. We had this on the schedule. Wow. Oop. Oh, okay, that's cool. Well, the game's still starting. That's not good. Get rid of this. Suppose we don't need the samurai sword. Ow. Get rid of that. Okay, the game's still starting. I don't think there's much I can do about it. I was hoping after cleaning that up, the game would stutter less, but no, the game's still starting. Also sip. Water. There it is. Oh, that went flying. Holy shit. To limit the risk of deadlocks, the executive performs the wait in intervals of 500 milliseconds instead of doing an infinite wait on the resource. After the end of these 500 milliseconds, if the resource is still owned, the executive attempts to prevent CPU starvation by acquiring the dispatcher lock, boosting the own thread of the boosting the owning thread or threads to 15 if the owner priority is less than the waiters and not already 15, resetting their quantums and performing another wait. Because the executive resources can either be shared or exclusive, the kernel first boosts the exclusive owner and then checks for shared owner and boosts all of them. When the waiting thread enters the wait state again, the hope is that the scheduler will schedule one of the owner threads, which will have enough time to complete its work and release the resource. Note that this boosting mechanism is used only if the resource doesn't already have the disable boost flag set, which a developer can choose to set if the priority inversion mechanism that described here works well with their usage of resource. Additionally, this mechanism is imperfect. For example, if the resource has multiple shared owners, the executive boosters all those threads. The executive boosts all those threads to priority 15. The result in the sudden surge of high priority threads on the system, all at full quantums. Although the initial owner thread will run first because it was the first to be boosted and therefore is the first on the ready list. The other shared owners will run next because the waiting thread's priority was not boosted. Only after all the shared owners have had a chance to run and their priority have been decreased below the waiting thread, will the waiting thread finally get its chance to acquire the resource. Because shared owners can promote or convert their ownership from shared to exclusive as soon as the exclusive owner releases the resource. It is possible for this mechanism to not work as intended. Okay, let me get off this hill first. By the way, the game is like running at like 37 FPS, just in case you're curious. Ooh, ooh. You almost fell off there. Okay, let's take a nap after we get off this hill. I can barely see anything, especially without a headlight. Well, okay, we can use our tail light, I guess. Okay. Take a nap. Priority boost for foreground thread. I can't speak today. Priority boost for foreground threads after waits. As will be described shortly, whenever a thread in the foreground process completes a wait operation on the kernel object, the kernel boosts its current, not base, priority by the current value of PS priority separation. The windowing system is responsible for determining which process is considered to be in the foreground. As described earlier in this chapter in the section controlling the quantum, PS priority separation reflects the quantum table index used to select quantums for the threads of the foreground applications. However, in this case, it is being used as a priority boost value. I haven't had anything to eat this morning just yet. We need a bumper. Can I put this on the back, perhaps? Yes. Okay, cool. I hope I haven't been around here yet. down here? Was that a shot? Is that a shotgun? It's a double barrel shotgun, isn't it? Hello, Doge. Okay. Wait. I've been here, haven't I? Uh-oh. That's not good. Uh-oh. It's all a flat circle? I hope not. Let's backtrack a little bit to the last, well, no. How about this? Next time we hit a fork, I'm gonna place down an object. The stream is so laggy on here. That's just the game. The game is laggy. The game is running at like 20 to 30 FPS. Like the stream is running fine. It's just the game is not doing well. Because this is a horribly optimized game. Right, the reason for this boost is to improve the responsiveness of the interactive applications. By giving the foreground application a small boost when it completes a wait, it has a better chance of running right away, especially when other processes at the same base priority might be running in the background. Ooh. Ooh. That's not too bad. Oh, I didn't close the... Aw, I forgot to close the cap. Okay, chat. You're gonna have to remind me. If I don't close the cap, please be sure to spam me in chat. Okay, that's not too bad. Just a few... Just, like, 1.7 liters, you know. No? Wow, okay. Especially when other processes at the same base priority might be in their background. Experiment. Watching foreground priority boost in the case. Using the CPU stress tool, you can watch the priority boost in action. Take the following steps. Open the system utility in the control panel. Right-click on the computer icon and choose properties. Choose advanced system settings, advanced settings, advanced tab. Select the program option. This gives the BPS priority separation of a value of 2. Run the CPU stress, right-click on thread 1, and choose Busy from the context menu. Now start the performance monitoring tool. Click the Add Counter toolbar, or press Ctrl-I. Select the thread object, and select Priority Current. In the instance box, select all instances and click Search. Scroll down to CPU stress process. Select the second thread, thread 1, the first thread in the GUI thread, and click the Add button. You should see something like this. That. Click OK. Okay, hang on. And... You guys can do this back at home. It's gonna scroll down. Priority boost after the GUI wake. Priority boost after the GUI thread wakes up. I notice I have one problem whenever I do these speeches. I kind of speak too fast, and I just end up jumbling words together. I don't know if there's a way I can slow down. Priority boost after GUI thread wakes up. Threads that own the window receive an additional boost of 2 when they wake up because of windowing activity such as arrival of windowed messages. The windowing system, Win32K, still applies the boost when it calls KSSet event to set an event used to wake up a GUI thread. The reason for this boost is similar to the previous one, to favor interactive applications. Once again, this is something you can read on your own, so we're not doing this right now. You can pause the stream. Priority boost for CPU starvation. Imagine the following situation. A priority 7 thread is running. preventing a priority 4 thread from ever receiving CPU time. However, a priority 11 thread is waiting for some resource that the priority 4 thread has locked. But because the priority 7 thread in the middle is eating up all the CPU time, the priority 4 thread will never be run long enough to finish whatever it's doing and release resources blocking the priority 11 thread. Okay, so here's what we're gonna do. We're gonna place a marker for where we're going. How do we do that? We're gonna use a cactus. Okay, there we go. We're gonna set up a tiny roadblock to show that we've been here on this specific branch. Okay. But because the priority 7 thread in the middle is eating up all the CPU time, the priority 4 thread will never run long enough to finish whatever it's doing and release the resource blocking the priority 11 thread. This scenario is known as a priority inversion. What does Windows do to address this situation? An ideal solution, at least in theory, would be to track locks and owners and boost the appropriate threads so that forward progress can be made. The idea is implemented with a feature called Auto Boost, described later in this chapter in this section, Auto Boost. However, for general starvation scenarios, the following mitigation is used. You saw how the code responsible for executive resources manages this scenario by boosting the owner threads so that they can have a chance to run and release the resource. However, the executive resources are only one of many synchronization constructs available to developers, and the boosting technique will not apply to any other primitive. Therefore, Windows also includes a generic CPU starvation relief mechanism as part of a thread called Balance Set Manager. The system thread that exists primarily to perform memory management functions and is described in more detail in Chapter 5. Once per second, this thread scans the ready queues for any threads that have been in the ready state, that is, haven't run, for approximately 4 seconds. If it finds such a thread, the Balance Set Manager boosts the thread priority to 15 and sets the quantum target to an equivalent CPU clock cycle of 3 quantum units. After the quantum expires, the thread priority decays immediately to its original base priority. If the thread wasn't finished and a higher priority thread is already run, the decay thread returns to the red queue, where it again becomes eligible for another boost if it remains there for another 4 seconds. Okay. Eliza, hello, Mecha. Welcome back. Oop, let me get off this hill first. Have I seen this part of the road yet? Because this doesn't feel familiar to me. Yet. I guess we'll see if we run into another thing we've already seen. Oop. Actually, that rock in the middle looks familiar, but don't know if I've actually seen it or not. Really hope we're not backtracking our progress, because that would suck. You know, it would be nice if the game has a hint as for how much of a progress I've made and is making, am making. This Balance Set Manager doesn't actually scan all the ready threads every time it runs. All of this is making me a true Windows engineer. Only if this is all it takes, I can still barely understand. Well, not barely understand, but There's so much to Windows. Now, Balance Manager doesn't actually scan all the ready thread every time it runs. To minimize the CPU time it uses, it only scans 16 ready threads. If there are more threads at that priority level, it remembers where it left off and picks up again on the next pass. Also, it boosts only 10 threads per pass. If it finds more than 10 threads meriting this particular boost, which indicates an unusually busy system, it stops the scan and picks up again on the next pass. Note that, as mentioned, the scheduling decisions in Windows are not affected by the number of threads and are made in constant time, because the Balance Step Manager must scan ready queues manually. This operation depends on the number of threads on the system. More threads require more scanning time. However, the Balance Step Manager is not considered part of the scheduler or its algorithms, and is simply an extended mechanism to increase reliability. Additionally, because of the cap on threads and queues to scan, the performance impact is minimized and predictable in worst-case scenario. I can now apply job and Windows. I use Linux Mint. So a lot of people think I main Windows. That is not necessarily true. I use both with Linux and Windows. I specifically main Arch on my laptop. And many of the things I use also are Arch-based. The server I have at home is Ubuntu. So I actually do use a healthy mix of Windows and Linux. I think I've been using Arch for like, I want to say 5 to 7 years now. A lot of people will think, oh, Windows bad. But I feel like there's usually nuance to this discussion, because like there are a lot of things that Windows particularly excel at, and so is the case for Linux. So I use a healthy mix of both, I think. Ooh, there goes the trunk. Get that back. Ooh, double jump. You have a home server? Yeah, where do you think all the VODs go? And I have like many home servers as well. That runs like a lot of self-hosted stuff. Many of the things I run are not dependent on third-party services. Like I have my own photo server. I have my own finance admin server, etc., etc. I'm jealous. Like it's literally just a PC I found in a junkyard. It's nothing extravagant. It does the job, you know. If it runs Linux, it's good enough. But that's it. I should probably swap out the C drive. The main drive on that thing, because like it is running low on storage. And for the boot drive, for the main drive. Anyways, back to what I was saying. I like to use both Linux and Windows. Windows is bad in certain things. Linux is also bad at certain things. Wayland is still not great, for example. The other day I realized Wayland doesn't do overscan. At least not that I could tell anyways. We are out of cactus. Is there any junk that we can place on the floor, perhaps? Suppose we can run back and then grab a cactus in the back. I want to have a home server to train LM model. Yeah, that's a different story. You're gonna need like something much more powerful. My server doesn't even have GPU inside. So the way I do GPU boosts at home is on my server is the things that I use that need an LLM or AI model. Those support Olama. So because Olama also works across networks, so I can just have the Olama instance running on my Windows machine, the main one, and have the thing connect to my main computer. That way I don't need a GPU in this system. It's probably not the fastest solution, but it works. Certainly cheaper than having to buy another GPU for the server. Cactus is very smart. You know, I'm surprised that it took me 10 streams to figure out that this is something I could do. So I'm gonna go this way. Yeah. Place this down. That's good enough. Okay. It's like that story. Was it the Little Red Hood or something? There was one child story that's like they place cookie crumbs on their way to somewhere, so like they can backtrack or something. Okay, you can check this experiment out yourself. All right, applying boost. The game is lagging more, which is a good sign. That means it's loading new stuff. Applying boost. Back in KI Exit Dispatcher, you saw that KI process thread waitlist is called to process any threads that is in the deferred ready list. It is here that the boost info. Hang on. By the way, we've lost like the headlight so many times. At this point, I've kind of given up on getting a working headlight. It is here that the boost information passed by the caller is processed. This is done by looping through each deferred ready thread, unlinking its wait blocks. Only active and bypass blocks are unlinked, and setting two key values in the kernel's thread control block list. There's adjust reason and adjust increment. The reason is one of the two adjust possibilities seen earlier, and the increment corresponds to boost value. KI deferred ready thread is then called. This makes the thread ready for execution by running two algorithms. The quantum and priority selection algorithm, which you are about to see in two parts. The processor selection algorithm, which is shown in the processor selection chapter later in this chapter. Let's first look at when an algorithm applies boost, which happens only in cases when a thread is not in the real-time priority range. For an adjust unwait boost, will be applied only if the thread is not already experiencing an unusual boost, and only if the thread has not been. I was like, was that coming from the game? No, that's the music. I'm heading towards the end of the playlist. Actually, I need to change a different one. Oh, you know what I need? I need like. Do I have the soundtrack for Go yet? That's a good playlist to play. Give me a second. By the way, I kind of want to replace my keyboard. Like, this keyboard has always been meant to be like a backup keyboard. But at the same time, I don't know if I feel like spending like another $100. I say that as I spend $100 on unnecessary things. The main reason is that typing on a black keyboard, like a cherry black, has been kind of cumbersome. I kind of want to replace it to something that's a little bit easier to type on. I have a yellow switch at work. That one's great. Give me a second. It's still loading. Okay, there it is. Alright, let's look for Go soundtrack. I still know how you're supposed to pronounce it. Go. Oh. Have they not released a soundtrack yet? Hang on. Is it on their Steam? I don't think so. Is it in the game only? Because if so, that sucks. Yeah, they haven't released a soundtrack yet. Huh. Well, that sucks. I mean, I suppose I could, I suppose I could have the, my browser, does that play it? Do they have it? Hell, I can't even find it on YouTube. What? No one's uploaded the soundtrack yet, really? What? The closest I can find is this 2-hour thing. No, that's just their stream. Well, that sucks. I was hoping I can play the music from that game, because the music is good. Well, that's fine. Guess we'll switch to, I don't know, let's switch to Celeste or something. Okay. Where are we? Let's first look at when the algorithm applies boost, which happens only in cases when the thread is not in the real-time priority range. For an just unweight boost, it will be applied only if the thread is not already experiencing an unusual boost, and only if the thread has not disabled boosting by calling set priority thread priority boost, which sets the disable boost flag in the K thread. Another situation that can disable boosting in this case is if the kernel has realized that the thread has actually exhausted its quantums, but the clock interrupt did not fire to consume it. It has come out a wait, which lasted less than 2 clock ticks. Less than 2 clock ticks sounds very small. If these situations are currently not true, the new priority of the thread will be computed by adding the adjust increment to the thread's current base priority. Here, redeem Doge. That threw me off for a little bit. Additionally, if the thread is known to be part of a foreground process, meaning that the memory priority is set to memory priority foreground, which is configured by Win32KSYS. Ooh, hang on. Are we at a fork again? No, we're not. Okay. This is where the priority separation boost, PS priority separation, is applied by adding its value on top of the new priority. This is also known as the foreground priority boost, which was explained earlier. Alright. We're at a fork again. No cactus inside. Damn it. Maybe I should, like, keep some cacti in my car. Yeah. Come on. No. That way. I wonder how much water is in the cacti. I know you can drink these things, but how feasible is it? Like, is it enough for you to survive an entire day? Okay. Finally, the kernel checks whether this new compound priority is higher than the current priority of the thread, and it limits the value to an upper bound of 15 to avoid crossing into the real-time range. I think I'll go right, actually. It then sets this value as the thread's new current priority. If any foreground separation boost was applied, it sets this value in the foreground boost field of the K thread, which results in a priority decrement equal to the separation boost. For adjust boosts, the kernel checks whether the thread's current priority is lower than the adjust increment. Recall this is the priority of the setting thread, and whether the thread's current priority is below 13, and if so, and priority boosts have not been disabled for the thread, the adjust increment priority is used as the new current priority, limited to the maximum of 13. Meanwhile, the unusual boost field of the K thread contains the boost value, which results in a priority decrement equal to the lock ownership boost. In all cases where a priority decrement is present, the quantum of a thread is also recomputed to be equivalent of only one clock tick, based on the value of KI lock quantum target. This ensures that foreground and unusual boosts will be lost after one clock tick instead of the usual two, or other configured value. As will be shown in the next section, this also happens when an adjust boost is requested, but the thread is running at priority 13 or 14 with boost disabled. After work is complete, adjust recent is now set to adjust none. Alright. Removing boosts. Removing boost is done in KI deferred ready thread as boosts and quantum recomputations are being applied, as shown in the previous section. The algorithm first begins by checking the type of adjustment being done. For an adjust non scenario, which means the thread has become ready, perhaps due to a preemption, the thread's quantum will be recomputed if it already hits the target, but the clock interrupt has not yet noticed. Oh, that's a lot of pebbles. As long as the thread was running at dynamic priority level. Additionally, the thread's priority will not be recomputed. For an adjust unwait or adjust boost scenario on a non-real-time thread, the kernel checks whether the thread silently exhausted its quantum, as in the prior section. If so, or if the thread was running with a base priority of 14 or higher, if no priority decrement is present, and the thread has completed a wait that lasted longer than 2 clock ticks. The quantum of this thread is recomputed as its priority. Priority recomputation happens on non-real-time threads. It's done by taking the thread's current priority, subtracting its foreground boost, subtracting its unusual boost. The combination of these last 2 items is the priority decrement, and finally subtracting by 1. This new priority is bounded with the base priority as the lowest bound, and any existing priority decrement is zeroed out, clearing unusual and foreground boosts. Let's go left. There we go. Oh. Hang on. Should probably make it consistent. I have it placed on the right side of the road. For the other ones that we placed this far. Alright. This new priority is bounded with the base priority as the lowest bound, and any existing priority decrement is zeroed out, clearing unusual and foreground boost. This means that in case of a lock ownership boost, or any of the other unusual boosts explained, the entire boost value is now lost. On the other hand, for a regular adjust and wait boost, the priority naturally trickles down to 1 due to the subtraction by 1. This lowering eventually stops the base priority when the base priority is okay. This lowering eventually stops when the base priority is hit due to the lower bound check. There is another instance where boost must be removed, which goes through the ki remove boost thread function. This is a special case boost removal that occurs due to lock ownership boost rule, which specifies that the setting thread must lose its boost when donating its current priority to the waking thread to avoid a lock convoy. It is also used to undo the boost due to targeted deferred procedure calls, or DPCs, as well as boost against e-resource lock starvation boost. The only special detail about this routine is that when computing the new priority, it takes special care to separate the foreground boost and unusual boost components of the priority decrement to maintain any GUI foreground separation boost that the thread has accumulated. This behavior, which appeared starting with Windows 7, ensures that the threads relying on lock ownership boost do not currently behave erratically when running in the foreground, or vice versa. Figure 4-12 displays an example of how normal boosts are removed from a thread as it experiences quantum end. Yeah, let's take a nap. We'll zoom in. Priority boosting and decay. So it was boosted all the way up here, and then the priority decay, anti-quantum end, so it goes down, and then goes down to preempt, and then finally it goes all the way back down to the default again. Alright. Not in the driver's seat. Priority boost for multimedia applications and games. That's what we're playing right now. That's what we're doing. Although Windows CPU starvation priority boost might be enough to get a thread out of an abnormally long wait state or potential deadlock, they simply cannot deal with the resource requirements imposed by a CPU-intensive application, such as Windows Media Player or 3D computer game. Yeah, imagine calling Windows Media Player something CPU-intensive these days. Shows how we've come a long way. Skipping and other audio glitches that have been ooh, damn it. Let's get the bumper back on. Thank you. Skipping and other audio glitches have been a common source of irritation amongst Windows users. The Windows user mode audio stack exaggerates this situation because it offers even more chances for preemption. To address this, client version of Windows uses MMCCS CSS driver, described earlier in this chapter, implemented under system root system32 drivers MMCSS. That's what it is. Its purpose is to ensure glitch-free multimedia playback for applications that register it. Alright, more flow fork. I think it's time that we got more cacti. Note that Windows 7 implements MMCSS as a service rather than a driver. This posed a potential risk. However, if the MMCSS managing thread blocked for any reason, the threads managed by it would retain their real-time priorities, potentially causing system-wide starvation. The solution was to move the code to kernel, where the managing thread and other resources used by MMCSS could not be touched. There are other benefits to being a kernel driver, such as holding a direct pointer to process and thread objects rather than IDs or handles. This bypasses searches based on IDs or handles and allows faster communication with the scheduler and power manager. Ooh, okay, that's not good. Okay, we lost a lot of things there. I swear, rocks are like the deadliest thing in this game. I think we lost a bumper or something, or door up there. What's deadly? The rock. Yep. We lost the door. Okay. Let's go back up. come on, you can do it. You can do it. You can do it. Nope, you can't do it. Okay, understandable. Well, we have to go back to the beginning of the road then. Client applications can register with MMCSS by calling avset mmthread characteristics with a task name that must be one of the subkeys under HKLM Software Microsoft Windows NT current version multimedia system profile tasks. This list can be modified by OEMs to include other specific tasks as appropriate. Where'd the door go? Which rock did we run into? Was this one? In what direction did the rock, did the door fly off to? Check the VOD. Oh, okay. Apparently it's right next to the rock. Here? Okay, I just blended them right in with the rock. Alright, come on you go. Thank you. So there's audio capture, distribution, games, low latency, playback, portable audio, and window manager. Each of these tasks include information about various properties that differentiate them. The most important one for scheduling is called scheduling category. Ooh, game lagging, that's good. I'm gonna destroy this cactus on my way. So we are in the new area at the very least. Oh, never mind. Which is the primary factor determining the priority of the threads registered with MMCSS. Table 4-4 shows the various scheduling categories. Alright, hang on. That's a foot. That's a engine, or I think that's a motorcycle engine. Yeah. How do these cars get in here? Hello? Anyone here? Hello? Fresh? I think he's upstairs. Yeah, I think he's upstairs. I don't know how I'm gonna get up there, though. I can't really get him from here, unfortunately. Oop, I have no idea what that is. There's not much usable here, except, well, I'll take that. Pretty sure we're gonna lose it right away, again. check the engine. So I kind of give up on the idea of finding a better engine because, like, whenever we take a new engine, it ends up dying in like 10 minutes. We snag a door? Oh, we have all the doors. I don't think we need one. Oh, that's a lot of oil. Not that we need that much oil, but I'm gonna drive the car a little bit closer. That door kind of ugly. I mean, is the other one gonna be much better? I'm wondering what I should do for the afternoon. Close. Yeah, I don't think that's much better. I like the hood though. Not that we can use it. Well, we can, but like, it's not gonna look good. Any idea for dinner? I'm not even sure what I want to get for lunch yet. Hello? Move the car a little bit. Strange, this is so peak. It sure is. Welcome to stream. I just don't have a talking AI next to me. I'll take this one. Alright, get it. Quiet down back there. That looks so ass. You know what? I'll take it. Anything else we can take? Yeah, just, I figured that wouldn't start.
There's going to be blood everywhere.
Okay, have fun. Bye-bye. I'm leaving now. Let me double check. Does this have a better door? On the left side, sure, but the right side it looks just as crap. I'm good. Okay, back to reading. So, scheduling priorities. So we have high, medium, low, and exhausted. So, I pressed the wrong button again. Hang on. How do I fix this? I can never figure out what I'm supposed to do when this happens. I guess reload. Oh wait, tab. There we go. Right. So hi. Pro audio threads running at higher priority can. Pro audio threads running at a higher priority than any other thread on the system, except for critical system threads. Medium, the thread's part of a foreground application such as Windows Media Player. Low, all other threads that are not part of the previous categories. Exhausted, threads that have exhausted their share of CPU and will continue running only if no other higher priority threads are ready to run. The main mechanism behind MMCSS boosts the priority of threads inside a registered process to the priority level. Matching their scheduling category and relative priority within this category for a guaranteed period. It then lowers those threads to the exhausted category so that other non-multimedia threads on the system can also get a chance to execute. Celeste OST is Celeste OST. I was gonna play the Go OST, but apparently it's not available on YouTube, and they don't sell it separately either. Unfortunately, they could just add it as DLC. I don't know why they didn't do it. By default, multimedia threads gets a 80% of the CPU time available, while other threads receive 20%. Based on a sample of 10 milliseconds, that would be 8 milliseconds and 2 milliseconds, respectively. You can change this percentage by modifying the system responsiveness registry under the HKLM software, Microsoft, Windows NT, current version multimedia system profile key. Perto, hello TNT. This value can range from 10 to 100%. 20 is the default. Setting a value lower than 10 evaluates to 10, which indicates the CPU percentage guaranteed to the system, not the register audio apps. MMCSS scheduling threads runs at priority 27 because they need to preempt any pro audio threads to lower their priority to exhaust the category. Alright, let's take a nap. You can't sleep yet. There it is. As discussed, changing the relative thread priorities within the process does not usually make sense. And no tool allows this because only developers understand the importance of various threads in their programs. On the other hand, because applications must manually register with MMCSS and provide them with information about what kind of thread this is, MMCSS does have the necessary data to change these relative thread priorities, and developers are well aware that this will happen. Experiment MMCSS priority boosting. In this experiment, you'll see effects of MMCSS priority boosting. Run Windows Media Player or other playback. Ooh, hello. That is an empty car. Okay, not much here. Play some audio content. Using Task Manager or Process Explorer, set the affinity of WM Player to use only one CPU. Open the Performance Monitor tool. Change the Performance Monitor priority class so that it will have a better chance of recording activity. Click Add Counter, Priority Current, yada yada yada. You can take a look at this part yourself. MMCSS functionality does not stop at simple priority boosting, however. Because of the nature of network drivers on Windows and the NDI stack, DPSCs are quite common. DPCS are quite common mechanisms for delaying work after. Ooh, I feel like I've been here before. Wait, I have been here before. Uh-oh. That's not good. We are circling. We've been here like 1 or 2 streams ago. I remember this place. Alright, well, I don't know which path we took last time, so I'm gonna... put down some cactus on the right. Is that right enough? I hope that's right enough. Ah, close enough. DPCS are quite common mechanisms for delaying work after an interrupt has been received from the network card. Because DPCs run at RQL level higher than user mode code, see Chapter 6 for more information on DPCs and RQLs. Long-running network card driver code can still interrupt media playback. for example, during network transfers or when playing a game. MMCSS sends a special command to the network stack, telling it to throttle network packets during the duration of the media playback. This throttling is designed to maximize playback performance at the cost of some small loss in the network throughput, which would not be noticeable for network operations usually performed during playback, such as playing an online game. Alright. Have we been here before? Based on the broken cacti, I assume that's a yes. Yep, that's a dead person. Okay, we've been here before. Which is bad. But that also tells us we can backtrack to the previous fork. That way we don't continue going on this road. You know, sometimes during these streams, I'm like so tempted to put on like Truckers FM or something like that. Because, Celeste OST is sleep-inducing, I would say. Which is not great when you're trying to drive. Can you imagine just driving in a circle for many streams? You don't have to imagine where you're looking at right now. Alright, we are out of cacti again. Cacti. The exact mechanisms behind it do not belong to any area of the scheduler, so we'll leave them out of this description. MMCSS also supports a feature called deadline scheduling. The idea is that an audio playing program does not always need to... Wait, so you're telling me we've been down this fork as well? Uh-oh. Ooh, that's not good. That's really not good. So we somehow circled to all of exhausting... we exhausted all the paths for this particular branch. Well... Oops. Should have done this cacti strat a little bit earlier. It only took me 10 streams to figure out this strat. Where did you get the strat from? In my head. I just thought of it randomly. Yeah, it only took me 10 streams to figure that out. I was so smart. I'm so smart. I invented this technique, in fact. Where was I? If such a program uses buffering, obtaining audio data from disk or network, then place a buffer while building the next buffer, deadline scheduling allows client thread to indicate a time when it must get high priority level to avoid glitches, but live with a slightly lower priority within this category in the meantime. A thread can use the AV task index yield function to indicate the next time it must be allowed to run, specifying the time it needs to get the highest priority within its category. Until that time arrives, it gets the lowest priority within its category, potentially freeing more CPU time in the system. Auto Boost. Auto Boost is a framework targeted at priority inversion problem described in the previous section. The idea is to track lock owners and lock waiters in such a way that will allow boosting the appropriate thread priorities, priority as well as needed, to allow threads to make forward progress. The lock information is stored in a static array of klock entry objects inside the k-thread structure. The current implementation uses a maximum of 6 entries. Each klock entry maintains 2 binary trees, one for locks owned by the thread, and the other for locks waited on by the thread. These trees are keyed by priority, so that constant time is required to determine the highest priority boost, to which boosting should be applied. If boost is required, the owner priority is set to the waiter's priority. Ooh, okay, hang on. It may also boost our priority if these were issued with low priority. See Chapter 6 for more on our priority. As with all priority boosts, the maximum priority achievable by auto boost is 15. The priority of real-time threads is never boosted. There we go. There we go. Current implementation uses the auto boost framework for push locks and guarded mutexes synchronization primitives, which are exposed to kernel code only. See Chapter 8 in Part 2 for more information on these objects. This framework is also used by some executive components for specialized cases. Future versions of Windows may implement auto boost for user mode accessible objects that have an ownership concept, such as critical sections. Context switching. A thread's context and the procedure for context switching vary depending on the processor architecture. A typical context switch requires saving and reloading the following data. There's the instruction pointer, kernel stack pointer, a pointer to the address space in which the thread runs, which is the process page table directory. Kernel saves this information from the old thread by pushing it onto the current old thread's kernel mode stack, updating the stack pointer, saving the stack pointer in the old thread's k thread structure. The kernel stack pointer is then set to new thread's kernel stack, and the new thread's context is loaded. If the new thread is in a different process, it loads the address of its page table directory into a special processor register so that its address space is available. See the description of address translation in Chapter 5. If a kernel APC needs to... If a kernel APC that needs to be delivered is pending, an interrupt at RQL1 is requested. For more information on APCs, see Chapter 8 in Part 2. Otherwise, control passes to a new thread's restored. Otherwise, control passes to the new thread's restored function instruction pointer, and the new thread resumes execution. Direct switch. Windows 8 and Server 2012 introduced optimization called direct switch that allows the thread to donate its quantum and boost to another thread, which is immediately scheduled on the same processor. In synchronous client-server scenarios, this can produce a significant throughput improvements because the client server threads are not mitigated to other processors that may be idle or parked. Where was I? Alright, there it is. Another way to think about it is that at any given time, only the client or the server thread is running. So the thread scheduler should treat them as a single logical thread. Figure 4-13 shows the effect of using direct switch. So before, T1 enters, threat 1 enters wait and wakes threat 2. And with direct switch, it just directly enters wait and awakes T2 like in a direct line on a single CPU, as opposed to having to context switch to CPU B. Hello, White Bear. How are you still awake? It's like early, isn't it? The scheduler has no way of knowing that the first thread, thread 1 in figure 4-13, is about to enter a wait state after signaling some synchronization object that the second thread is waiting on. Therefore, a special function must be called to let the scheduler know that this is the case. Atomic signal and wait. But weekend? True. By the way, also, yeah, I won't be awake for very long. Yeah, I should probably not stay up too late. By the way, I did wake up, or like stay awake for a little bit. I did wake up and then stay awake for a little bit for the evil ASMR. I completely forgot that was happening, by the way. Apparently that happened after the Pokemon stream. That was an experience of the occasional yelling in your ears. I assume there was no stereo though. Because like I was listening in my bed with speakers all the way up. Right, where was I? Hang on, let's take a nap first before we go on. Oh, things are loading. That's good. All right, let's take a nap here. We only got one message from Points, but I'll have to watch the rest on VOD. Since I was talking to friends. Yeah, you know, I haven't really watched back on any of the stream moments that I missed. I haven't watched any of the VODs yet. Because, like, there's just so much content right now. For the twins, for the turtle. Oil. Take that. He's having a coughing fit. Wait. Gotta remember to do that. It's like, do these tankers have anything inside? Oh. Watch me snipe him from here. Here we go. Holy shit. 629 liters of diesel. I don't need it, but Jesus. At least it's technically SMR, so I won't have to focus too much. Yeah. I'll leave it running in the background. Oh, with the occasional metal pipe sound. You know, sometimes I wonder what the audience age range is for Neuro. I have to imagine it's probably attracts a lot of teenagers as well, right? What the heck is this? No idea. Oh, Jesus. Oh, there goes oil. Damn it. Ooh, gas. Maybe. The reason why I ask that is because I checked the audience metrics on my on Colorful Array cover. It's actually mostly adults. There is a small percentage of teenagers as well. Just thought it was interesting. I think most of our covers, majority of them are like adults for the ones that check out my stuff. Alright, just use a freaking gun instead. Ooh, headlights. Not that I need it, but I'll take it. I also need to reload my gun. Don't need it right now, but I'll put it here. And, how do I do this again? Open cylinder. Right. Uh-huh. Okay. So we have like 3 different car parts here. 1 up on the roof somehow. And 2 in the garage looking thing. Where are the cars? No battery, no gas. No battery. I assume that's battery. Alright, not much useful here. Diesel. Oil. Okay. Nothing usable here, I would say. For oil or gas, that'd be great. But no. We are 35.7. We'll be fine. Alright. If possible, the KI direct switch thread function performs the actual switch. It's called by KI exit dispatcher if past the flag indicating the use of direct switch is possible. Priority donation, in which the first thread's priority is donated to the second thread, if the latter's priority is lower than the former. It is applied if specified by yet another flag to the KI exit dispatcher. Ooh, okay. That's a flip. Okay, that could have been worse. That's not too bad. Okay, door. I mean, I am a teen. Yeah, it's true. Doge. Oh, headlight flew off again. Glad I caught it. I know why mostly adult want you. So, by the way, another reason why I'm kind of curious is because a lot of Nero's friends are Mostly intended for mature audiences. That's also another reason why I was like, slightly curious. In the current implementation, these two flags are always specified together, or not at all, meaning if any direct switch attempt, priority donation is attempted as well. Direct switch can fail, for example, if... God, I freaking hate these headlights. The adults are children pretending to be adult. That's me. So what sparked this conversation was because in my head I was kind of thinking chat's general behavior. It's pretty funny. I'm part of the chatters, but like, I love Twitch chat. I think it's a core part of the experience. Alright, I'm gonna need to run into this. I'm gonna grab the cacti. By the way, I think they were also once again hate rated earlier during the Evo ASMR stream. I don't know if it was hate rate, but like a lot of first messages showed up. Maybe just chat hoppers or something. This is weird because like it's like this is like the third year the Neuro started doing these. Well, technically the second year, but like, well, third year, yeah. It's technically the third or second year that Neuro started doing this, and she's just now getting, I've never seen a hate rate before. Not on Neuro's channel, anyways. I thought I don't know too many younger Neuro fans, but also realized I don't spend too much time with teenagers anymore. Well, at the same time, it's also like, it's usually not too much of importance to know whether or not whoever you're talking to is adult or not. Well, for most cases. Sure, a lot of them just blend in. Like, technically, yeah. I'm gonna go this way. For example, if a target thread's affinity precludes it from running on the current processor, however, if it succeeds, the quantum of the first thread is transferred to the target thread, and the first thread loses its remaining quantum. Direct switch is currently used in the current in the following scenarios: if the thread calls signal, object, and wait, Windows API, or the kernel equivalent NT signal and wait for a single object, or ALPC, asynchronous something procedural call, I forgot. Synchronous remote procedural call, RPC calls, or COM remote calls. Currently MTA or multi-threaded department. 2 MTA only. I mean, only recently Jen and I started getting into commercial products and LLMs are getting everywhere, unwanted. Yeah, like, also, I don't know, some people realize Neuro Evo are not just generated, but have to hire a small army to get this project going. I mean, that's always been what makes Neuro a lot less of a quote-unquote bad AI. It's that the majority of what makes Neuro works requires a lot of it's, even though it's like primarily run by an LLM, but also not really, because like most of the work related to Neuro are human labors and human arts, and that's what makes Neuro feel a little bit more human than whatever other companies are pumping out. Like, I understand why people don't like the idea of Neuro if they don't know what makes Neuro work and what the community has been through. Even songs aren't just generated but have a singer behind them. Yeah, or covers. Yeah. If it were like, for example, if there was a Grok powered stream that's running 24/7 on Twitter, yeah, you can hate radio side. Hate the billionaires, whatever. I'm usually pretty against AI these days. At least the mass commercialized AI, like generative arts, etc. Those I'm like, yeah, I think I'd rather not have any AI of any sorts. But like, you know, it's inevitable. Like, it was already a thing, even back in when I was in university. Homework suck. I hope you're not doing your homework through just LLM. Hope you're actually learning, studying. But yeah, I wouldn't say the hate rate isn't exactly warranted if like they didn't know how Neural works. At the same time, though, it's like, do your homework before you come in here and be like, ooh, yeah, bad. But yeah, I wouldn't say the hate isn't exactly unwarranted. It's just not. At least they're angry at AI in general, which I understand. Just Neuro isn't. I wouldn't say it really fits in that category because it's like mostly human driven. There's a lot of human components into each stream, and Vito also understands that if you just let an AI stream for 24/7, that's also bad content because people are gonna get worn out. And it's gonna be like mass generated media content that loses its value. I think Vito has claimed many times he's not as smart as many people think, but I think he's really smart in terms of a business side of things. And it also helps that many of your friends are real streamers with a lot of charms to them. Not all of them, but like, you know, majority of the Neuro's friends are what many people like. Vito has said many times on the stream, he's like, yeah, I'm not as smart as many people think. It's just my work is built off of Claude and other things. At the same time, though, I'm sure there's a lot that goes on in the background. I mean, having to run a large channel like this and having to do game development on the side as well. Like, for example, I think he's already done a lot more than a certain other software, right? At least he's got a game out. That's complete. I'm gonna take this. Thank you. Take a nap. I might go to Zukia for lunch later. Because I think by the time I'm done with the stream, it'll be like 2 p.m. or something. It's currently 12:14 p.m. I can't imagine what education is like these days. Not that LLM has to be taken into consideration. Because like the other day I was like grading papers for the summer boot camp that we do. Sorry, the winter boot camp that we do every year. And there's been a significant uptick in the LLM usage. We did indicate that if you do use AI, you need to let us know. And there were a handful of people that didn't disclose their AI use, and I thought it was very eh. We also deducted some points off of them as well for not disclosing. At the same time, though, there are people that have disclosed it. The problem is, another big problem I've noticed is that the students will feed the data to LLM, and then they just regurgitate it, or sometimes even copy paste the result into the report. In some cases, I've even seen placeholder lines that AI generates, and then the student forgot to remove the line, or like, or the paragraph is clearly written from an AI's perspective to the user, i.e., here's what this means, here's what you should do, in a tone that it's the LLM talking to the user, as opposed to the user, the student, talking to whoever's grading the paper. Sometimes also surprised how 1-2 from you. Okay, that's not too bad. I'm sometimes surprised how 1-2 from UK got AI right, while all these mega corporations have heads too far into making the products that won't annoy their customers. After scrolling LinkedIn, I'm not surprised. I had a friend who copied things Wikipedia 101, even the number. I genuinely don't know how these people live with themselves. Like, there's some, do they not? Personally, I think there would be some moral that will violate my moral standards, I would say. Also, speaking on the topic of hello Doge, welcome back on Twitch. We go. Okay, nothing flew off. Sip. Speaking of mega corporations and things that won't annoy their users, Twitter, X, whatever you want to call it. I always call it Twitter. The whole edit image thing. Like, what did they expect? As in, like, what did whoever implemented that expect the community is gonna react to it? I think Twitter has become like really, really bad for artists in general. A lot of people are also talking about Blue Sky as an alternative, but I don't know how realistic Blue Sky will be able to replace Twitter just because of how big it is already. But anyways, back to Twitter, right? The whole Grok situation has gone so out of hand. Like, and there were, on my Twitter timeline, I would see like there are artists complaining about how there are people replying in their replies tagging Grok. It's like, turn her around, or replace her top with bikini, or some creepy shit like that. Like, not just for artworks. There were some people were doing it even on cosplayer threads or pictures. Like, don't do that. But at the same time, the edit image kind of also made things worse. Because, like, now you can just, like, do the same thing, but in secret. Because, like, you don't have to, like, when you click on the edit image, you can type in the prompt to alter the image. But instead of just adding it to the reply, you can also just download the image or screenshot it if you wanted. And that's bad. there are extensions that can make Twitter more tolerable, like control panel for Twitter, which hides most of these garbage crap from you. But that doesn't really solve the fundamental problem with the platform, because like not everyone uses the same thing, and you know you can't use the same thing on an app, for example. Think about open source shit though. The thing is, open source is usually good, but at the same time, the data sets themselves aren't open source. How do you know they haven't poisoned the model in any way? And I would argue, even if they did that, the overall negative impact that many of the LLMs and AIs have done are their negative impacts outweigh the positive impacts. You can just download image and use Grok privately. I tested it works. Adding armor, animate character, other edits should work, but people are just too lazy. Yeah. You can run many of these models. There are many models you can check out on Hugging Face as well. Not just like these mainstream models. Have I been here before? That's a no. Bye-bye. I should probably get back to reading. I've been blabbering for like 10 minutes. I mean, for them at least, you need some good PC, and Grok have private chat for free. Yeah. Which, by the way, I have tried out Annie a few times. The Grok companion is what I'm talking about. At first I was like, okay, that's not too bad. But then I realized, like, for some reason I kept defaulting to Japanese. It thinks I'm Japanese for some reason, and I kept trying to like change it back to English. And then I realized, oh wait, it's literally just starting a new Grok thread. Like, you can, if you check the Grok chats, you'll see that a thread has been created every time you start a companion session. I was just realized, oh, it's literally just Grok's chat, but like with avatar slapped on top. And like, I did try to have conversations with it. Like, for example, I tried to ask it for life advice, like very generic ones. I'm not actually looking for advice. It just felt so fake. It's positive for me because some dumbass no longer has to write a 10-page essay. You say that, but there's a reason why you're writing an essay in the first place, because it's meant to help you in some way, or for you to think about whatever you're writing about. If you rely entirely on LLM, you're going to lose the ability for critical thinking. Once again, I'm not against AI, but I think there should be a healthy balance for what you do with it. Like, I'm not gonna be a hypocrite and say I don't use AI. Like, I do use AI. I do use LLM. I do use it for work. Particularly when it comes to solving code and writing scripts and figuring out how certain things work. I'm not going to be a hypocrite and say don't use them, but I think there's a healthy balance you should have in knowing and just remembering that it's there to help you, but not replace whatever thinking that you have to do on your own term. Like, back to this example that I was talking about when it comes to grading students' paper. It's clear that many of them didn't think critically about whatever they were writing about, and they end up giving me a paper that's like horribly written. There was this one student that the entire paper was AI generated, and none of the facts that I wrote in there are correct. If you had placed some critical thinking into what the AI puts out, then I think that could be easily avoided. Like in time, I'm gonna move to Alaska anyways. Only vibe code though. I think vibe code is generally fine. Like I do use Claude to help me with like scripts and some website stuff occasionally. I don't use Cursor or anything like that though, because that requires paying. Also, aside from mortality, I think it'll backfire. Like Facebook and YouTube first encouraging people to generate content and then cracking down on it. It's taking too much space and nobody wants to watch it. Probably poison data. Speaking of, I'm surprised the inspiration tab is still a thing on YouTube. Like, if you're a creator, if you go on your back end, there's a tab called inspiration, and like it'll generate a list of topics and even the thumbnail based on things you've already created, and it just comes up with these nonsensical topics for you to talk about. That doesn't make any sense. I don't know if anyone uses that tab. I hope no one does. All right. Back to reading, though. Actually, hang on. I might need to take some meds for my throat. Right. Okay. Scheduling scenarios. Windows answers the question of who gets the CPU based on the threat priority, but how does this approach work in practice? The following sections illustrate just how priority-driven preemptive multitasking works on the threat level. A voluntary switch. A threat might voluntarily relinquish the user processor by entering a wait state on some object, such as an event, a mutex, a semaphore, an IO completion port, a process, a thread, and so on. By calling one of the Windows wait functions, such as wait for a single object or wait for multiple objects. Waiting for objects is described in more detail in Chapter 8, Part 2. Figure 4-14 illustrates a thread entering a wait state and Windows selecting a new thread to run. In Figure 4-14, the top block, which is a thread, is voluntarily relinquishing the processor so that the next thread in the ready queue can run. This is represented by the halo it has when in the running column. Although it might appear from this figure that the relinquishing thread priority is being reduced, it is not. It's not just being moved from the wait queue. It's just being moved to the wait queue of the object that the thread is waiting for. That's a nice flip. Surprised the headlight didn't fly off there. Right, as you can see, it's like bouncing off of it and it hits the ready state. Preemption. In this scheduling scenario, a lower priority thread is preempted when a higher priority thread becomes ready to run. This situation might occur for a couple of reasons. Excuse me. A higher priority thread's wait completes. The event that the other thread was waiting for has occurred. A thread priority is increased or decreased. In either cases, Windows must determine whether the currently running thread should continue to run or be preempted to allow a higher priority thread to run. I'm gonna go left. I am out of cactus again. Cacti. Any cacti around here? No? How about this? I'll leave this here. Not ideal, but we need to collect some cacti on our way. Note that threads running in user mode can preempt threads running in kernel mode. The mode in which the thread is running does matter. The thread priority is the determining factor. When a thread is preempted, it is put at the head of the ready queue for the priority it was running at. It's like from wait state and bounce down to here. Not you. There we go. By the way, I think I might do a just chatting stream with Go running in the background. So we can get a few things done after his stream, after I get lunch. It's not gonna be anything too significant. Let's take a nap real quick. For figure 4-15, a thread with a priority 18 emerges from a wait state and repossesses the CPU, causing the thread that had been running at priority 16 to be bumped to the head of the ready queue. Notice that the bump thread doesn't go to the end of the queue, rather it goes to the beginning. When the preempting thread has finished running, the bump thread can complete its quantum. Quantum end. Speaking of end, that's a dead end. Hang on. Let's try another path. Oop. Not like that rock. No, I'm still waiting for Riedel to resume. Oop, I'm still stuck. Hang on. This playthrough of this game, I don't think he's ever gonna do it, but one can hope. I wonder if Coco still plays this game. She said she liked this game, and she has like 200 plus hours on it. Alright, I'm gonna go this way instead. Quantum N. When the running thread exhausts its CPU quantum, Windows must determine whether the thread's priority should be decremented, and then whether another thread should be scheduled on the processor. If the thread priority is reduced, for example, because of some booster received before, Windows... another dead end. Okay. Well, we'll definitely have to wrap around this then. Woo! Careful. Okay, nothing fell off, I think. Okay, both of our headlights are still there. Good. For example, because of some booster received before, Windows looks for a more appropriate thread to schedule, such as one already in the ready queue with a higher priority than the new priority of the current running thread. If the thread priority isn't reduced, and there are... Oop. You know, it just occurred to me, it's been a while since we last saved. Should probably do that. Oh, take your follow. Neko Nyan Nyan Nyan. Hello. That sure is a very Neko name. Welcome to stream. Let's save first. Save. Been a while since we last saved. Alright, where were we? If the thread priority isn't reduced and there are other threads in the ready queue at the same priority level, Windows selects the next thread in the ready queue at the same priority level. It then moves the previously running... Okay, I need to... Hang on. Before I continue reading, I need to focus on getting the car back on the road. Should I get ChatGPT or just... ChatGPT Mini or ChatGPT? I didn't even know there's a Mini. Realistically, if you were to ask my opinion, neither. Because, like, I never liked ChatGPT's output. Ooh. Get back here. Get back here. Get back here. Like, so, of all the AI mainstream AI models, I'd rather use Gemini or sometimes even Grok over GPT. DeepSeek wouldn't let me log in. I wouldn't even use DeepSeek even. I kind of wish there were like better open source models personally. That way I don't have to run everything in the cloud, but if I do have to choose, I'd probably choose Gemini. Gemini 3 still isn't great. I guess the job done for the most part. Alright, then moves on to the previously running thread to the tail of that queue, giving it a new quantum value and changing its states from running to ready. This is illustrated in figure 4-16. If no other thread of the same priority is ready to run, the thread gets to run for another quantum. As you can see in this thread there, sorry, the picture there. As you saw, instead of simply relying on clock interval timer-based quantum to schedule threads, Windows uses an accurate CPU clock cycle count to maintain quantum targets. Windows also uses this count to determine whether quantum end is currently appropriate for the thread, something that might have happened previously, and is important to discuss. I don't know if Gemini can do commus. What do you mean? Like, wait, huh? Using a third scheduling model that relies only on clock interval timer, the following situation can occur. I'm gonna go straight. Thread A and B become ready to run during the middle of an interval. Scheduling code runs not just at each clock interval, so this is often the case. Thread A starts running, but is interrupted for a while. The time spent handling the interrupt is charged to the thread. Interrupt processing finishes, and thread A starts running again, but quickly hits the next clock interval. The scheduler can only assume that thread A had been running all this time, and now switches to thread B. Or thread B starts running, has a chance to run a full clock interval, barring preemption or interrupt handling. In this scenario, thread A was unfairly penalized in two different ways. First, the time it spent handling a device interrupt was counted against its own CPU time, even though the thread probably had nothing to do with the interrupt. Interrupts are handled in the context of whichever thread was running at the time, as discussed in Chapter 6. It was also unfairly penalized for the time the system was idling inside that clock interval before it was scheduled. Figure 4-17 illustrates the scenario. So thread A and B becomes ready to run at the first interrupt. At the first interval. Thread A, and there's interrupt in between, and then interval tries to run thread B. Even though for the majority of part, thread A was only run for a tiny little bit, is what I assume it's trying to say. Okay. Let's take more cacti with us. Before I do that, let me turn down the space here that I have next to me. It has gotten cold enough that I had to bring out my space heater. I just jump out the window. That's something I can do, apparently. Me realizing this 10 parts into the stream. I can't imagine playing this with survival elements enabled. Like, constantly watch out for things to eat and whatnot. I'm good. Driving is like enough already. Unfair time slicing in pre-Vista versions of Windows. Windows keeps an accurate count of the exact number of CPU clock cycles spent during work that the thread was scheduled to do, which means excluding interrupts. It also keeps a quantum target of the clock cycles that should have been spent by the thread at the end of the quantum. Therefore, both of the unfair decisions that would have made against thread A is, as described in the preceding paragraph, will not happen in Windows. And instead, the following situation occurs. Thread A and B becomes ready to run during the middle of an interval. Thread A was running, but interrupted for a while. A CPU clock cycle spent handling the interrupt are not charged to the thread. Interrupt processing finishes, and thread A starts running again, but it quickly hits the next clock interval. The scheduler looks for the number of CPU clock cycles charged to the thread. Okay. Aren't we glad that we put down the cacti? We've run into our first repeated cacti already. Okay, so we've been... Okay, so that means we gotta put a cactus on the right here. I'm so glad that we started doing this. Otherwise, I would have run in circle again. Alright, this way. Okay. Intro processing finishes and thread A starts running again, but quickly hits the next clock interval. A scheduler looks at the number of CPU clock cycles charged for the thread and compares them to the expected CPU clock cycles that should have been charged at quantum end. Because the former number is much smaller than it should be, the scheduler assumes that thread A started running in the middle of a clock interval might have been additionally interrupted. Thread A gets its new quantum increased by another clock interval, and the quantum target is recalculated. Thread A now has a chance to run for a full clock interval. At the next clock interval, thread A has finished its quantum, and thread B now gets a chance to run. Holy shit, this is a huge rock. I'm gonna have to wrap around. Okay, I won't be able to read during these off-road segments. Because I'd rather not run into another freaking rock. But let's take some of these cacti. Okay. My throat is getting tired already. I mean, to be fair, I've been talking for 2 hours, 10 minutes. Ish. Where's the road? Come on. Actually, I won't be able to see anything in this lighting condition. Take a nap. Okay. That sure is a rectangular rock, holy. Okay, I assume that's the road over there. Just gonna go for a straight line. I assume this is where we're supposed to go. Or is it that way? So I'm gonna go on a straight line. And they're not encouraged to do this, but I'm gonna see where this takes me. wonder if I should have hot pot or sukiya for lunch. I wonder if Sukiya still does sukiyaki in our area. Okay. Well, at least I didn't die from that. Could have been worse. Surprisingly, the headlight did not fly out. Alright, I see a road. I'll be taking this road then. Alright. So yeah, thread A was interrupted in the middle of the first interval, and then Windows was like, hey, you get to run another full clock cycles. Enter interval 2 for thread A. And it goes back to running thread B in figure 4-18. Termination. When a thread finishes running, either because it returned from its main routine, called exit thread, or was killed with terminate thread, it moves from the running state to the terminated state. If there are no handles open to the thread object, the thread is removed and the process from the process thread list. And the associated data structures are deallocated and released. Idle threads. When no runnable threads exist on the CPU, Windows dispatches the CPU's idle thread. Each CPU has its own dedicated idle thread. This is because on a multiprocessor system, one CPU can be executing one thread while the other CPU might have no threads to execute. Each CPU's idle thread is found via the pointer in that CPU's PRCB, wherever that is. All the idle threads belong to the idle process. The idle process and idle threads are special cases in many ways. They are, of course, represented by eProcess, kProcess, and eThread, kThread structures. But they are not executive manager processes and thread objects, nor is the idle process on the system process list. This is why it does not appear in the output in the kernel debugger's !process00 command. However, the idle thread or threads and their processes can be found in other ways. Oop. 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 Okay, nothing fell off somehow. Okay. Experiment. Displaying the structures in the idle threads and idle process. You can do this on your own. The preceding experiments show some of the anomalies associated within the idle process and its threads. The debugger indicates that the image name of idle, which comes from the eProcess structure's image file member, but various Windows utilities report the idle process using different names. Task Manager and the Process Explorer calls it System Idle Process, while TList calls it System Process. The process ID and thread IDs, the client IDs, or CIDs in debugger's output are 0, as are the PEB and TEB pointers, and potentially many other fields in the idle process or its threads. Because the idle process has no user mode space address, and its thread execute no user mode code, they have no need. That's not what I meant. They have. Hang on. Can we do so many things at once? They have no need of various data required to manage a user mode environment. Also, the idle process is not an object manager process object. On that cactus diet. On that cactus diet, indeed. I'm just throwing them out the window. Instead, the initial idle thread and idle process structures are statically allocated. And the lights pop back out again. Might go in. No, it didn't. Oh, there's another big rock I gotta drive around. Really? Or not? Takes a left here. And then it goes into a rock. Okay, we do have to drive around it. Cool. Save real quick. I'm getting kind of hungry. It's 2 hour 30 minutes into the stream. It's like lunch hours. Actually, it's a little past lunch hours. 12:57. I have chips next to me. Oh. There it is. Instead, the initial idle thread and idle process structures are statically allocated, and they used to bootstrap the system before the process manager and the object managers are initialized. Subsequent idle thread structures are also allocated dynamically. As simple allocations from non-page pool bypassing the object manager, as additional processors are brought online. Once process management initializes, it uses a special variable, PS idle process, to refer to the idle process. Okay, I'm gonna take a quick break from reading. My throat is getting tired. I'll put down the cactus here. Oh, that's not what I meant. Can I see my health right now? Hope I'm dying. I think there's health in this game, right? This music sounds so ominous for a Celeste soundtrack. Sorry, I'm trying to lock in on the driving. I don't want to run into any pebbles on the road. So I think I'm going to switch to a different soundtrack. This soundtrack is a little bit too ominous for me. Okay. should really get more soundtracks from Lana Rain. I only have a handful of tracks from her. Or albums. Good composer. Okay, I feel like we've hit different terrain. This feels... Okay, we've been here. That's not good. Was there a fork earlier? Let's go back to previous fork. I wonder how far we are from Disneyland. I feel like very far is the answer. Makes me wonder if we're ever gonna see like the end of this game before we finish reading part 1. I feel like we won't even be done with the game when we reach part 2. Just a reminder, we're like 1/4 of the way through part 1. We are currently on page 280 out of 801. How far are we from IKEA? Too far. Want some meatballs. Run into some cactus while on our way there. Just in case we don't have enough indicators. Okay, that's the fork I was looking for. Or not. Okay, so I assume we drove in the straight line. So I guess we'll put one here now. I assume this is not the way we came from. Wonder if we should do a Euro Truck Simulator at some point. By the way, I think the colorful ring cover, I think it's approaching 10k views. It's currently 9k, I think, a weekend, which is really good compared to what my usual covers go for. There were actually quite a few, by the way, there are quite a few comments talking about there should be like, ooh, hang on. There should be like a Neuro Teto collab. Driving a truck while distracted sounds amazing. Yeah, that's kind of what we've been doing all these streams. It's not truck. Also, let's take a nap. By the way, I was wondering if YouTube changing the username to handle thing was like a settings that I need to go change somewhere. I looked it up. Apparently, it's like this for everyone now, which is kind of annoying because like everyone's user handle is like gibberish. I assume it's also gibberish for you guys, for the handles. You didn't have a good username set up on YouTube. It's kind of annoying because like whenever someone joins the chat, I'm like, okay, how do I say your name? Or what's your username? Proper username. I'm hungry. Is that another fort coming up, or... I think? Yes. Okay. There's one more thing I want to do. So, I think we should also drop some cacti before hitting the fork. That way we know which way we came from. Hello, Crispy. Welcome back. Hopefully it doesn't dox my school email. You can change your handle if you wanted. I'll go this way. Let me just start collecting more cacti again. Mine still says 6 pixels followed by a bunch of numbers. If that's the intended username, then yeah, that's good. Oop. How are you doing tonight, Crispy? Did you get anything for lunch or dinner? Not sure if underscores help. I mean, as long as the username is like readable, it's not too bad. But if that's like gibberish, then that won't be very helpful. Okay, we haven't been here yet because that thing just got its physics updated. This guy convoy truck. Oh, well, we needed some cacti anyway, so we might as well grab them. By the way, I was checking out Twitch analytics back end for a little bit, a day or two ago. And I was like, viewers shared with your channel. Your viewers also watch these channel. Vito987, Lena, Krelly. Wow, it's like my viewers came from Nero's channel or something. That's just really funny to see. Which, by the way, if you came from Nero's channel, welcome. Thanks for stopping by. Oh, What the hell happened there? What was that? What? Huh? What? What did I even run into? What? Okay. Well, it's not too bad. Is it because of this cactus? Nope. Okay, we are missing a trunk and a door. Oh yeah, by the way, there's one thing I forgot to mention in the 2026 stream. We did hit like one major milestone this year, or last year. And that's, we hit 1,000 followers on Twitch. Which is great. Thanks to everyone that has followed over here on Twitch. I don't know if we'll hit 2K this year. We'll see. If I manage my expectations, realistically, I'm gonna be like 1.5K or something. Quote me on that. By the end of the year. I feel like hot pot for lunch would be too much though. Especially if I'm just having the hot pot by myself. But there's a very good, popular hot pot chain that recently opened up. Okay, not recently, more like a year ago. But I haven't had a chance to go check it out yet. I mean to go, but at the same time, I don't know if I can have realistically too much food. Like, I don't know what their serving size is. It's gonna be too much for one single person. Hot pot equals best dating food? Yeah. I would agree. Or like, not even just dating, but like, in general, it's like a good food. Type of food. When shared with others. I don't know about you guys, but like hot pot is like extremely common here. Like there's so many like, there are, you know, your sit-down places, and there are the very casual mom and pops run hot pot places, etc., etc. But they're everywhere. It's very common here in Taiwan. I think I'm done reading for today. My throat is getting tired. I wonder how much longer until we hit the next chapter. Because the entire Threads chapter is kind of flying over my head. I know I've said this many streams already. But specifically the Threads chapter, it's like... yeah... okay. And we have some idea of how things work now for Threads. But realistically, unless I'm actually implementing it, it's just very conceptual. Here you pick it, then they cook it. So hot pot is as much of it as a dish yourself. So for hot pot here, it's you're usually given a fixed amount of ingredients. Like they'll give you a bowl of like pre-selected sets of ingredients, and you cook them yourself. They'll bring over the pot of the stock and whatnot already, and then you pretty much cook it however you like. And usually, when I'm at a hot pot place, I usually have like a plate of sauce to go along with it, and possibly a bowl of rice. Depending on where you go, there are like very hot pot sizes that are like clearly meant for one person. That's the thing, though. I don't know if the place I'm about to go. Well, depending on, I'm not even sure if I'm going there necessarily today, but I'm gonna go check if there's a line. If there's a line, I might not bother. But if there isn't, then I guess I'll go see how big their serving size is. It's not too big. Otherwise, I'm just gonna have Sukiya again. Okay, by again, I mean like it's been like a week or two since I had last had Sukiya. Gyudon kind of deal. I've never been to Sukiya. It's basically like it's basically Japanese fast food. It's beef on rice, beef ball, basically, and it's a very popular Japanese chain. I have it whenever I want to have just a little bit more food than usual, but also want something quick. I hope I'm not like, I hope I'm on the right pace for where I'm going. It might be time we pick up more cacti, actually. In you go. Thank you. Me and my 1,000-pound cacti in the driver's seat. I'll go straight. Not good enough? Not good enough. Or you could zoom out, actually. You know, if Coco didn't say there's an ending to this game, I would assume that there's no ending. I'm just driving for the sake of driving. Because, like, how many hours have we spent in this game? Too many. Actually, how many? Let me check. Oop, hang on. Where's my Steam? There it is. I've been playing for 41 hours. It feels like it's been forever. How does Coco have like 200 hours in this game? What the hell? I think that's what she said, right? 200 hours? Oh, it was a long time ago. It was like a year ago since I last heard that. I think the game is no longer like stuttering quite as badly as before. I mean, it's still running at like 30 FPS, but like, you know, it's not like jumping up and down now. Okay, let me park. Nap. By the way, I think the weather here has been cold enough that I don't think the lava lamp is working quite well whenever you were streaming. Like, I can see the wax block has kind of solidified a little bit. I assume it's just not cold enough, sorry, not warm enough for the wax to be pushed up and down. Ooh. Almost ran into that. We lost our headlights again at some point. What the hell, man? How do I keep losing my headlights? Every time when we do these streams, like, headlight stays on there for like an hour of the stream if we're lucky, and then it's gone. Oop, careful. I think for the just chatting stream later, I can do, like, I have a few things I want to work on. I need to get ooh, okay. Trunk hood fell off again. Of course it always does. I want to get Xenosaga Episode 2 working, as well as I'll work on thumbnails for next week. It's a blow-up doll. Very cool. Oh, thanks. Cool. Oh yeah, I have a backup headlight there, so you can use this one. A little bit bigger than what I usually have, but sure. How much gas do we still have? Okay. 30 liters, 40 liters. Okay, that's not too bad. Just to drive for a while. By the way, I think I need to start... Oh. Ow. Hello, Doge. I think it might be time for me to start looking for hard drive options again. Either that, or I can just start uploading. I think maybe I'll offload some of them to like a B2 storage. Because like, I've been trying to squeeze out more storage lately. Transcoding some of the older footage to AV1. That's something I have already been doing since like a year ago, but for my existing streams. I've been trying to get more squeezed out. But like our 16 terabyte ZFS storage is like running out. Has been running out for a little while actually, if it weren't for the transcodes. So I think I might start to offload some of them onto B2 offline storage. Granted, I don't know if I'm ever gonna use those old footage, but you know, I think I'd rather keep them around than not. Yeah. Hello.
Don't be afraid.
Hello.
I'm just
I did
trying
just
to
walk
rip
through the
off
wall.
your
Oh my god.
face and use it as my own.
Bye bye. Anyone else here? That's a lot of hats. Hello? Hello? Bye-bye. Shotgun ammos, I think. Oh, that's a cigarette. AK, sure. Funkiest looking AK there is. I wonder how many shots it takes to kill someone with it. What is that? In the game, I mean. In Minecraft. Ooh. Free ammo. Free magazines, I mean. That's radiator, that's thing. That is what it was this. Oil. This is only 0.5. We don't really need it. We need gas more than oil, I think. I guess I'm playing CS again. I haven't played CS in a while. And is that another AK? That's another AK. Another 30 bullets. What the hell is that? Attach. What? Okay. That's a door. What's of all these AKs? Oh my god. Okay, well there wasn't a whole lot here, unfortunately. I'm gonna check the outside though. Nothing here. It's a trailer parked. That one's empty. Let's get that out. Alright, with that, I think I'm gonna call it here. I'm tired. I need some food. I might do a casual just chatting stream after I'm done with lunch, depending on how I'm feeling. For now, who can we raid? I don't even know who's alive at this hour. Raid. If it would show. Hello? There we go. Rosa is streaming. Sure, let's rate Rosa. I had nothing to do but watch us all day. Well, that's good. We're gonna do more just chatting stream a little bit. But for now, I'm gonna send you guys over to Rosa. Wow, I have 6 viewers watching. That's more than usual. Alright, I'll see you guys later or something. Yeah. Bye-bye.